Good morning, everyone. Today, I'd like to spend my time to look over an issue that's often underestimated, and that is furniture wastage. Although several individuals may argue that furniture wastage isn't really an issue, it is an extremely alarming conflict within our planet's sustainability. For example, the Environmental Protection Agency stated that in 2024 alone, approximately 10 million pieces of furniture was gone to absolute waste. Along with this, the European Environmental Protection Agency stated that approximately 14.4 million pieces of furniture was gone to absolute waste. This is extremely frightening because that is approximately over 1 million pounds of resources of natural material gone to absolute waste. In order to solve this increasing and alarming sustainability conflict, we propose an AI-driven solution to solve this issue: FurnishFind.
FurnishFind is an AI-powered website that will find the best second-hand collection for your room, and it prevents wastage. It works like this. And here it'll give you the top 3 furniture recommendations for your room. If you click here, you can find the website on eBay.
Ideally, we would have wanted a data set of semi-furnished rooms and the ideal furniture piece to go along with it, because that would have made it very easy to train a model that can help us figure out what furniture pieces would go well in a room. But unfortunately, after searching thoroughly, we could not find any such data sets. So we had to be smart in the way we train our model. Instead, we found data sets of well furnished rooms on Kaggle, IKEA, and Getty Images, and other various sites.
Alright, so right here is our web scraping algorithm. We import these libraries and we set the service class for the WebDriver right here. And these are our URLs these are exemplary URLs to get the data of these furnished rooms. Along with this, we just scrape the images right here, and we can kind of test this out by running this class right here. And when we do this, the images get scraped and they be sent to the living room module right here, this folder, and it basically just scrapes all these images, and currently it's doing them right now as it's loading.
Unfortunately, since we had thousands of images, some of them were not good images. Some of them did not have a lot of furniture, like in the example here, or some were not well furnished. So we used the ChatGPT 4.0 Vision API to determine which images did not have well furnished rooms and discarded them. Then we used YOLO V8 to identify and segment out each individual piece of furniture inside these well furnished rooms. And after we extracted them, we used the exact segmentation mask and left every other area filled with black space so that there would not be any other context surrounding these extracted images. Then we try to train a model to predict, given a room, which furniture piece was in the room and which wasn't. We used a mask to cover the furniture piece we removed, and then we had a furniture piece we removed from the image and then a random furniture piece. And the goal of the model was to predict which furniture piece belonged, because if it could do that, that means it understood which furniture went well in a room and which did not. Specifically, we used contrastive learning to do this. We used a Room CNN, which was a variant of a ResNet 18 CNN that was pre-trained on ImageNet, to get a embedding of a room, and then to get embeddings of each of the pieces of furniture. Then we tried to train it with backpropagation to make the embeddings of the matched pair more similar and the embeddings of the non-matched pair more dissimilar. Specifically, we used a triplet loss in order to achieve this kind of contrastive learning. And in 20 epochs, we were able to achieve an accuracy of 89.7%. After performing web scraping on an eBay site of secondhand furniture listings, we again used the exact same YOLO V8 methodology to extract exact segmentation masks of furniture. We then ran that furniture through a furniture CNN to get embeddings of each of the furniture images. Then in the Flask, in our in our backend, we had a we had users input an image of the room, and then instantiated a room CNN, which we used to create an embedding of each of the rooms, and then checked in a vector database to find the closest matches of furniture that matched with the room to give recommendations for users for the best furniture pieces for them to use to be more sustainable while making their houses look better. Thank you.